Hello guys, so in this video we are going to see this particular problem, count hills and valleys in an array. So let's first understand what the problem says is, so it says you are given a zero index integer array nums and index I is a part of hill in nums if the closest non-equal neighbor of I are smaller than nums I. Similarly, an index I is part of valley in nums if the closest non-equal neighbors are larger than nums I. Adjacent indices I and j are part of same hill or valley if nums I and nums j are equal. So basically, it is what it is saying is you will be given integer array nums where each of the indices of the nums will define a particular height. Okay, so suppose these are the height. Okay, so these are the heights. So here these two are same. Then this is it. Then this is there, and let's keep another one. Okay. So basically, this is our array. So we are given one, two, three, four, five, six indices. Okay. So what they are saying is any particular index, if on the left hand side whatever the number is, if on the right hand side whatever the number is, which is greater than this particular number, so this will be a valley. This will again will be a valley. This will be a hill. This will be a hill. This will be a valley, and this will be a hill. So basically, what they are saying is, these two points that you are seeing, these two belongs to the same value. Okay, so basically if you see, these two are only one value and not two values. This is one hill, this is another hill. If we have something like this, okay, this is one point, then we have this, then we have this, then we have this. So this is also a hill, this is also a hill, but they belong to the same hill. Okay, not different one. So basically we'll count them as one only. So that is what they are saying is, the hill definition they have given, the valley definition they have given, and here they have given adjacent indices I and j are part of the same hill or valley if the numbers are equal. So if the numbers are equal, they belongs to the same hill or they belongs to the same valley. That is what they are saying. What we have to do is note that for a number, for an index to be a part of hill or valley, it must have non-equal neighbor on both left hand side and right hand side. So basically, if this has to be a hill, then we have to check the one that is on the left which is not equal and on the right which is not equal. Okay. So if you see this particular example 2 4 1 1 6 5, so if we draw the like diagram, so it will be 2, then it will be 4, then it will be 1, then again 1, then it will be 6, and then it will be 5. So if you see something like this. Okay, so how many like hills are there if we count? So this won't be calculated as a hill. This will be our first hill, H1. This will be our second hill, H2. And how many valleys are there? So if you see, you can see two numbers are there, but they will be belonging to the same valley because their values are equal. Okay, so they belong to same valley. So number of valleys equals to 1. So total number of hills 2, total number of valleys is 1, so total value is 3. That is what they are asking. So what this problem can be like simplified by doing what? Well, while iterating over this array, just remove the duplicates that we have, the adjacent duplicates. So once we remove the adjacent duplicates, what we will be remaining is 2 4 1 6 5. Now once we are remain with this, we have to just go over each index and check like the left and the right one. If this is a value, like if both of them are greater, then this is a valley. If both of them are smaller, then this is a hill. That's it. Nothing else has to be done. So let's see the code. Uh, that's it. The problem doesn't have anything else. So if you see here, this particular part of the code, what I'm doing here is I'm creating a stack and then I'm putting everything inside the stack and like keeping in mind that the numbers should not be repeated. Okay. So for example, if I take 2, 4, 1, this for first example, first I have put 2, then I have okay, let me take here. First I have put 2, then I have put 1, the 4, then 1. Then again when 1 comes, we'll see the top of the like the peak of the array. If it is equals to 1, then what we are doing, we are removing it until the top is not equals to the num that is coming, that is 1 that is coming. So 1 is not equals to 4, so we'll put 1, then 6, then 5. So this will be our final array, and then we are putting that inside this nums. You can see we are converting this stack into an array and then putting in the, and then simply iterating over each of the elements, and then we are deciding whether the like the number itself, the current one, is less than left and the number is less than right. In that case it is a valley and we do count plus plus. Otherwise, if num is greater than left and num is also greater than right, then count plus plus, that is, it is a hill. So that way we are doing count and then we are just returning this count value. Okay. So if you want to see another example, let me try to take this. So if you see this double six double five four one, so what we are doing, we have inserted six. Now again six is coming, so we will see the top of the stack, that is it is six. So we are going to remove it. Nothing is left. Then six we have inserted. Then we have inserted five because these two are not equal. The top and the incoming one are not equal. Five. Then the incoming one is five. So the top and the incoming are same. So we'll remove this. Now the top and the incoming are not same. So we have put five here. Now 4 is coming, like 4 incoming one and the top one not equal, so 4 1, similarly 1 here. So finally, what is the array that we are remaining with? 6 5 4 1. So adjacent duplicates are removed. Now we are simply doing, okay, 5 is there, the left one and the right one both are not greater, not smaller, so need not to take this. Same with 4. So same with 1 and same with 6. So answer is 0. That is what it is here. Okay. So let me try to submit this particular code and we'll see. Okay, see, so the code is submitted and it is faster than 33% of the submissions. So this is it. You just have to keep this in mind that we have to remove the adjacent duplicates. You cannot remove it or you can do it in the code itself. I prefer this way because that way I'll get a fresh nums where the duplicates are not there. So this part will become easy. So that is why I removed first and then use the removed one as an example. Okay. So I hope you would have liked this video. This code will be present in the description of the video, so you can go ahead and check that and let me know in the comments how you have liked the video, if you have any doubts in the code. Okay, thank you.